Hello, it's great to be here for another GNU Radio conference. My name is Dave Miller, and for my lightning talk, I'm going to provide an overview of my project on the feasibility of using GNU Radio to build a very high data rate modem using only GNU Radio software blocks, no FPGAs and no graphics processing units. And what do I mean by very high data rates? Well, at least 10 megabits per second with BPSK. A little background, I provided a paper and talk at a previous GNU Radio conference on operating GNU Radio up to about 2.0 megabits per second. The Moore's law stagnation, however, for a single core over the last 10 years or so really limits the data rates one can achieve with GNU Radio to about 3 megabits per second and 6 megabits per second for BPSK and QPSK respectively. So can we overcome that 6 megabit per second limitation? An Aerospace Conference 2020 paper, I think, provides a path forward. Can the approach in that paper be used with GNU Radio? Basically, with the approach, we break up the complex IQ stream into chunks. Then we process the chunks simultaneously in parallel cores, and then the frame stream is stitched back together again in order by using the frame header counter. The purpose of this project is really to demonstrate that data rates well above 6 megabits per second can be achieved with this parallel multi-core approach. Scope: BPSK at 10 megabits per second, a laptop with an 8-core CPU, version 3.8.3 of GNU Radio, an Ubuntu operating system, a dongle with a high-rate USB 3.0 interface, and I conducted a test with a RF loopback test configuration that is shown at the bottom of this chart. This chart depicts the GNU Radio flow graph that I used for this project. The flow graph has 4 chunk chains in parallel. Each chunk chain has its own Symbol Synchronizer block and Costas Loop block. Before the Symbol Synchronizer blocks are the skip head blocks and the keep M in N blocks, and they are used to break the incoming stream into 4 slower rate overlapping streams. At the bottom of the flow graph are the out of tree modules I used, the frame stitcher block, the tag ASM blocks. The modulator blocks are shown in the lower left corner. For modulation, I transmitted a pre-recorded BPSK modulator file at 10 megabits per second. This chart depicts the modulator flow graph. I used this flow graph to generate that pre-recorded BPSK modulation file. For the flow graph on the previous chart, I used a pre-recorded modulator file because otherwise I would have needed more than 8 cores to run all these modulation blocks and the receiver blocks at the same time at 10 megabits per second. This chart here depicts how I distributed the blocks to the 8 cores. GNU Radio actually has a built-in affinity setting feature that was very helpful for this project. So, results and conclusions. I was able to operate GNU Radio at 10 megabits per second BPSK with the approach I've been talking about with parallel cores. For a lot more details on this project, please see the associated paper that will be in the conference proceedings. Future work: this approach should be scalable to data rates a lot higher than 10 megabits per second. Just add more cores, add more parallel chains. In the near term, I want to add a QPSK 20 megabit per second capability. So that concludes my talk. Thanks everyone for listening.